So now we quickly just want to go through section B and section C and see what's up. Okay, we want to quickly go through section B and section C. So if you remember our section B, okay, our section B is for right angled triangles. Okay, so here's it. We have section A is bearing, right? Then section B is right angled triangles. Then I'm gonna put this and I'm gonna remove it after. Section C, if you remember, section C is for non-right angled triangles. Okay, non-right angled triangles. So they're still triangles, but they don't have a right angle. So that is going to be our sine rule and our cosine rule, and our area being equal to half AB sine C, if you remember that. So that is going to be sine rule and cosine rule that's coming in here. And then section C, it is section D, section D, I'm going to say it like this. Our section D is no triangle at all. Okay, no triangles. We are only going to do trig graphs, and we'll do trig equations. Okay, trig graphs, and we'll do trig equations. So that's the structure. Don't ever forget it. So right now we are focusing on section B, which is right angled triangles only. So only a right angled triangle. So this question, we will need to see a right angled triangle. Okay, now section B, okay, this one has, we could say 2 parts. Sometimes we could say 3 parts. Okay, so depending on whatever. So we could call it 3 parts. Let's do the first one. First one is going to be the area. Okay, area being equal to base times height over 2, which some of you might know as half base times height. Okay, it's base times height over 2. You get a right angle triangle, whatever. We don't care about where it's looking, but once you see this sign of a right angle, then you get this as 5 and this as 7. 7 centimeters, 5 centimeters. They could give you this as 9. We don't care, 9 centimeters. And then they can ask for the area. So in here, we would say area is equal to base times height over 2, which is going to be, our base is going to be 5. That's the bottom value, times the height would be 7, all over 2. And we'll get our answer in centimeters squared. Okay, area will be centimeters squared. 7 times 5 is 35, so you get 35 over 2 centimeters squared, which would be 17.5 square centimeters, like this. And you're done. That's the first part. Now, the second thing which you're going to look at, very important, is going to be the Pythagorean theorem, or you might hear it being mentioned as the Pythagoras theorem. Okay, Pythagoras theorem. Okay, should I say Pythagoras theorem like this? Yeah, theorem. Okay, now this one I'm going to put in brackets. When we use this, we use this when we have sides only. Remember, it is going to be a right angled triangle, and you would get sides only. Okay, so there would be, you would get 2 sides, and you'll be asked to find the third one. Okay, for a right angled triangle, then you're going to have to use Pythagoras. So what does Pythagoras theorem say? It just says you'll be having a triangle like this. Okay, right angled triangle like that. Okay, it could come upside down like this, still the same with your right angle here. So what Pythagoras basically says is you have to find the side that is opposite your right angle. So if I go opposite my right angle, this side, I'll call it C, is the side code C. The other 2 sides would be A and B. Okay, we don't care which one is A, which one is B. We don't care, but C has to be the one opposite your right angle. So here I would come and say opposite my right angle is this. That is going to be C. Okay, and C is the hypotenuse. Okay, we call it C, right? It'll be our hypotenuse. Don't forget that. Hypotenuse, the side opposite your right angle. Okay, the other 2 will be A and B. We don't care who is A, who is B. Pythagoras theorem says C squared, which is the side opposite the right angle, we squared, it is equal to A squared plus B squared. This is what the Pythagorean theorem says. That's what Pythagoras theorem says. And we should be able to use this to answer any type of a question where you are going to get two sides and be asked about the third one. Okay, so I'm going to leave it here. We'll do examples of questions and in the next video. Here, what I want you to then know again, which is the third and final thing which we're doing here, is so ka toa. So ka toa. And these, we call them the trig ratios. Okay, trig ratios. We have the sine ratio, cosine ratio, and the tan ratio. They're called trig ratios. Okay, so ka toa, right? And in this one, what we are going to do is we are going to be finding, you'll be getting, I'm going to put in green, you get two sides and an angle, sorry, one side and an angle. So you get side and angle, okay? Side and angle. Or you get two sides and be asked to find an angle. So I'll say side or sides, and then angles are involved. So in here, in this one, there is going to be an angle involved in the question. Either you are going to be given an angle or you're going to be asked for an angle. And it will be a right-angled triangle. Once you see a right-angled triangle and they ask you for an angle, then you have to use SOHCAHTOA. And what does SOHCAHTOA say? What is SC and T? Why did we put them in caps? They're called trig functions. So, trig functions, we have three of them. Okay, here, which is sine, cos, and tan. We only have to know these three. So we have sine, cosine, and tangent. Okay, and tangent. Sine is the one which we see in the calculator as sine in short, cosine just as cos, and tangent just as tan. Okay, these are your trig functions. You say sine x, of course, and whatever. Okay, but these are trig functions. They always have sine of something, of an angle, sine of something. And then we have the sides, which are only three. H is for hypotenuse. So we have the hypotenuse, which is called side H. Then after that, we have the adjacent side. Okay, or you hear somebody say adjacent. And that's going to be your A or capital A, we don't care. Okay, and then O is going to be the opposite. So we have the opposite side, which is capital O, small o, capital O, it doesn't matter. Okay, so here hypotenuse H or H, it's not a problem. So there we go. These are the three sides, and there we have as the functions. So how you read this? When you say so, then ka, then toa. Don't forget the H, so, with an H in front. Ka with an H, then toa. So now when you're doing this, what you must remember is, what does so mean? S would be sine of the angle, which is theta, is equal to O is the opposite divided by H, which is the other one, hypotenuse. So sine theta is opposite of hypotenuse. And you'd say cos theta is equal to A is adjacent over H is hypotenuse. So cos theta will be A over H. That's how we write it. Then tan will be O over A. Okay, the first one over the second one. That's how you do it. So now, what is it that you must know about this type of a question? What you're going to do is you're going to get a question and it'll be a right angle triangle. And you must be able to label your sides. So, could be like this. You have a right angle. Then you're going to have some angle called theta. Now, you must be able to label the sides. Then you can apply the question. So now what we're going to do is opposite the right angle is hypotenuse. We don't call it C now. We just call it H. Then opposite your angle is the opposite side, O. Then the third side is adjacent. Okay, let me put a triangle like this. Right angle. And then let's put theta up here. So here's your theta. You first go opposite the right angle. That's going to be your hypotenuse, H. Then opposite the angle is going to be your opposite side. Then the third one is going to be adjacent. So that's what you need. That's all you got to do. Now that you label the things, you must then be able to use the one which works in that question. Because you have so, ka, toa, you're only going to use one. Either so or ka or toa. So what you do is, you look for a side which is not part of the question. Okay? You haven't been given that side, and you're not looking for it. Okay? It's not a side you're going to use in the question. If you haven't been given it, you're not using it. So it's not a side you have been given in the question. It's not a side you're using. That side is the side which you will go and remove. So let's say that we don't want the opposite. Okay, there is nothing. Here there is 7, here there is 5. They say find the angle of theta. So we see that opposite has nothing. So we are going to eliminate him from the question so that we know who to use. So anyone that has O for opposite is going. So goes, then Towa goes will remain with Ka. So we will now have to just write that cos theta is equal to adjacent over hypotenuse. That's how it works. And you can go ahead, tackle the problem, and find your solution. You see how it goes? That's how you do it. So yes, this is it for some of it. We'll do many questions and we'll see what's up in the next video. If you are to look for theta, you take cos to the other side. Theta will be cos goes to the other side. It becomes cos inverse of A over H. So that's how you do it. And you'll be done. You can get it. So that's how you solve these ones. Let's see many questions in the next videos that come. Bye for now.